All right, well, good morning, everyone, and thank you for joining us today. My name is John McClellan, and I'll be moderating today's webinar. Today we have Dr. Doug Marshall, who will be presenting allergen management through environmental monitoring. Dr. Marshall is the Chief Scientific Officer for Microbiology at Eurofins. He has over 20 years experience in academia and industry. He's also the co-founder and director of the Food Safety Institute, an integrated consulting and analytical services company affiliated with Eurofins. He currently holds an adjunct professor positions with Colorado State University and Florida State College. His research and expertise has been featured in many popular press venues, and his outreach interests focus on improving the microbiological quality and safety of foods. We're pleased and very excited to have him here with us today sharing his experience on this topic. Now, before we go ahead and get started, just a couple of housekeeping items to go over. This webinar is being recorded and will be available within the next 2 days for your viewing. So please submit any questions that you have throughout the presentation, and if we have time at the end, we'll go ahead and address them. How you go ahead and submit those questions, you'll notice there's a little place on the question panel here. So to submit a question, click the questions area in the GoToWebinar dashboard, and then type your question and click send. And again, if we have time at the end, we'll go ahead and answer those. And if we don't, we'll follow up individually with you and make sure we get all of your questions answered. So with that, I'm going to go ahead and turn things over to Dr. Doug Marshall.
Thank you, John. I really do value everyone's time to join us for this webinar. And let's go ahead and get this puppy launched. What I'm going to talk to you today is the importance of managing your allergen control programs through an environmental monitoring plan. And so the highlights that you're going to get today would be a review of the essential plan elements that we think are important for you to manage environmental contamination opportunities in your facilities. For those of you not familiar with Eurofins, I have just a couple of introductory slides for you. Eurofins' mission is very simple. We wish to improve the health and safety of consumers globally. And most of the markets that we serve, we're the #1 independent third-party laboratory consulting and auditing firm in those locations. Worldwide, we have over 200 facilities in about 36 countries. We employ over 16,000 employees. We have an analytical portfolio of greater than 100,000 analytical tests. In the United States, we have a number of service facilities and laboratories located geographically in every corner of our great country. Our main service areas are highlighted in this slide. So we have a primary interest in analytical chemistry and analytical microbiology related to these service categories. And one of the things we're going to talk about today is in the upper left, the contaminants. We're going to drill down into allergens. As most of you know, allergens, although they may not cause a large number of foodborne outbreaks or illnesses a year, they do cause the largest number of recalls due to undeclared allergens. So these are going to be allergenic proteins that have the potential to injure or kill a consumer that are not declared on a label, hence the recall. So what we're going to do is talk about how do allergens then get into those food products. So there are a number of ways in which allergens can cross-contaminate in a facility. These include the items listed on this slide. So in many parts of the world, raw agricultural commodities are using shared harvesting sacks, shared transportation vehicles, shared storage bins, transport vehicles, and so forth. And so there is an opportunity for cross-contaminating raw agricultural commodities during these steps of the food chain. We also have many allergenic carriers or flow aids that may be used as processing aids but may not necessarily be declared on the ingredients or materials that you're receiving. So in this case, what you're really doing is, if you're a manufacturer, you run a high risk of inheriting your supply problems. And anything you can do to reduce that inheritance issue will go a long way to controlling allergens in your final products. And then lastly is one that has a huge amount of problems, and that's just simply failing to declare the presence of an allergenic protein or an allergenic ingredient on a finished product. In terms of intentional adulteration, we've had a very recent example that is causing worldwide headaches. And I just want to use this as a contemporary example. There are many of these in history, but this is one that a lot of people are worried about currently. In this case, there is a peanut allergen warning because traces of peanut protein have been found in the spice cumin. And what is not exactly clear today is this unintentional contamination or intentional adulteration. And so on the left, I've got a picture of ground peanut shell, and on the right, I've got a picture of cumin, ground cumin. And you can see that it would not take any genius to understand that cutting the cumin with a bit of a lower value peanut shell could potentially introduce peanut protein into this product. And so again, this is we're not sure if this is intentional adulteration or unintentional, but this is just a very recent example. I want to review kind of the ways in which a food manufacturer can control allergens in their facilities. So just a quick review, these are the food safety management plans that most food processors are deploying in their facilities. So we have GMPs, SSOPs, HACCP, and with FSMA, we're also introducing some additional programs that provide additional pillars to keep that old roof on. And these include environmental monitoring programs, such as for pathogens and allergens. And again, today's focus is going to be exclusively on EMP programs for allergens. But you could also look at supplier verification programs and the role of audits to be able to qualify suppliers to make sure that allergen controls are a part of their food safety management plans. Some additional preventative control programs are listed on the next slide. And these include training programs for managers or workers, written records, batch records, validation of control programs. And then down at the bottom, I have 4 things. Yes, obviously I work for a testing laboratory business, but the role of testing can be very important to qualify your raw materials and your suppliers, to qualify in-process materials, and making sure that testing of your finished products are free of contaminating allergens. And then lastly, which again is going to be the bulk of what we're talking about there, is testing of the processing environment. So traditionally, what you've done to qualify a food contact surface in terms of whether it's clean or not is using a visual inspection. So is there residual food contaminants on those surfaces and so forth. Unfortunately, we know from the microbiology world that oftentimes visual assessment is insufficient to be able to assess whether or not those surfaces are indeed clean and sanitary. And we can say the same thing about allergens. And so as we've evolved to measuring whether our cleaning and sanitation programs are effective, we've had to introduce some testing programs to be able to develop that empirical data to answer those questions. So again, why are food allergens of concern? There are greater than 160 foods that we know are able to cause symptoms in susceptible individuals. These allergy symptoms are going to be caused by species-specific proteins that are found in the agricultural commodities. The symptoms can range from being very mild reactions, such as mouth itching, tongue swelling, face flushing, and so forth, or they can be very severe. So you can get your trachea expanding to the point where you can cause respiratory failure, ultimately leading in death. Unfortunately, there is no curative regime for individuals who are allergen sensitive. So their only opportunities for prevention is early intervention with treatment or avoidance. And if you are an allergen-sensitive individual or a family member of an allergen-sensitive individual, you will know that avoidance is the primary coping mechanism, and that can severely limit food choices. So it's a very, very unfortunate situation, and food manufacturers generally don't do a great job in helping these individuals with food choices. And then lastly, improper label declaration can cause consumer exposure, and obviously it leads to many, many recalls. So why would you want to test for allergens? First and foremost, our customers that are doing allergen testing, both in product, in ingredients and raw materials, and of their environment, they're very concerned about protecting their brand and reducing their liability. There are regulatory expectations that may be in place to, in certain jurisdictions, to be able to make sure that you have evidence that you have allergens under control. You can test to validate the effectiveness of your food safety management plans, such as your HACCP plan, validating CCPs, and in your sourcing supplier verification programs and sourcing raw materials and ingredients. And then also making sure that whatever your in-product label is has an appropriate label that declares allergens that are present in the product. You can also test to validate the effectiveness of your EMP programs. Some of your customers may expect you to do testing to validate whether or not there are allergens present in the products you're selling them. And then obviously if you have compliance issues, testing is important. So there are many different regulatory jurisdictions around the country. Don't have time to go through all of those, but I just want to give you a quick example of the regulated food allergens in the United States. So these include milk and the associated milk proteins, eggs and the associated egg proteins, fish, some of the common ones are listed there, crustacea, tree nuts, and this is one that some people have difficulty with because what is a tree nut? And coconut is an example of one that a lot of debate about. Ground nuts such as peanuts, grain products, and oilseed products such as wheat and soybeans. In other jurisdictions such as the United States, they have additional cereal products, particularly those that contain gluten, and so these are listed here. They also have a broader list of tree nuts, and those are shown down at the bottom of the slide, as well as some additional things like celery, mustard, and sesame, sulfur dioxide and sulfites, which aren't proteins but are inorganic compounds that are able to cause sensitivity, as well as some additional items such as lupine and mollusks. So what are some of the elements that I think are important for you to have in a formalized allergen control program? And these bullet points list some of those programs that I think would be valuable for you. First of all, the fact that you're here taking this webinar solidifies the first bullet point, and that is training of processing and supervisory personnel is incredibly important. Within your facilities, being able to segregate items, this could be raw materials as well as ingredients and finished products, to make sure that you've got proper segregation during storage and handling in your facilities. If you are using shared processing equipment that is processing allergen-containing materials as well as non-allergen-containing materials, making sure that you have validated cleaning procedures to remove those allergens when you're going from an allergen-containing process to a non-allergen-containing process. The next one is making sure that you prevent cross-contact during processing, and this includes things like scheduling production runs. So in other words, running at the start of the day after an effective cleaning and sanitation routine, running non-allergen product first and then following up by allergen-containing product would be a good way to segregate temporally those production runs. Being aware that if you are doing rework in similar kinds of products, making sure that you're not adding allergen-containing rework back into a non-allergen-containing product. If you have the capital to be able to manufacture facilities on dedicated production lines, this can include an entirely new facility or just segregation within a facility. That would be very helpful. Where most companies get into trouble is failing to declare an allergen on a product that contains allergen because the wrong ingredient label is used on those products. And then also making sure that you're not inheriting your supplier problems through a supplier control program also is very important. Some additional items include that ingredient control. In other words, know what you're buying, making sure that your suppliers know what they're providing with you, and then making sure you're using test data to validate what your supplier is giving, and making sure you're telling your supplier that you're going to do periodic test validation, and that helps keep them honest. And then including a facility mapping program is also very important so that you fully understand where allergen-containing ingredients and materials and products are flowing through your facility. So again, this helps you identify potential cross-contact points. Furthermore, within that allergen control program, cleaning is an absolutely critical step. And when I say thorough cleaning, how do you define that? Well, you can do visual assessment, but I would also argue you need to do allergen testing to be able to completely validate that that cleaning program is effective in removing allergens, both from easy-to-clean spots, but more importantly from hot spots that may be lurking within equipment or in your facility. Making sure that your personnel and equipment is not being used to transport allergen-containing materials and non-allergen-containing materials. So you may wish to segregate both your employees as well as the equipment and tools that you're using in your facility. Again, the segregation of allergen-containing and allergen-free ingredients and materials, rework control. One thing that is often overlooked on the microbiology side, but I think it also has influence on the allergen side, is looking at your air and dust control programs. Because again, if you're blowing using pneumatic kinds of transport systems, you really have the potential to blow dust throughout the facility, and some of that dust may contain allergenic protein. And then water control, in this case, you want to make sure that that water is not transporting allergenic protein from a hot spot into areas that you think are clean. So why would you want to do allergen environmental monitoring? I'll give you a few perspectives. So there could be a regulatory perspective. Your customers could make that expectation on you if you're providing them with material. Obviously, I think most important is your expectations. In other words, what are you doing to protect your brand? So environmental monitoring, I just want to carefully define what it is and what it isn't. So environmental monitoring is an essential component of your allergen control programs, but it is not in and of itself a control measure. It's simply an assessment tool that you use to be able to answer the question, are my environmental control programs working or not? And one way you assess that both is doing finished product testing, but also looking at your environmental monitoring testing. So testing can be an expensive proposition for many manufacturers. So if you choose not to invest your insurance policy dollars, what are you inheriting then in terms of risk? Well, first and foremost, you probably increase the potential for injuring or killing your customer. I would argue that that's not a long-term effective marketing strategy, and nor do I think that it has, for most people, something that you want to pursue as a company policy. You also are going to increase the costs associated with intrinsic and extrinsic factors related to recalls. You run the risk of facility closure and loss of business. Certainly you damage your brand reputation. And I would also argue that you would have no liability protection because, again, when auditors, inspectors, and customers are reviewing your facility and your management plans, many are expecting you to have allergen control programs. And so if you don't do that, and industry is expecting that, then that demonstrates that you lack prudence. And if I'm a lawyer who is representing a plaintiff in a lawsuit, I have a very, very easy case against you because you really don't have any liability protection. So let's talk quickly about a regulatory perspective and a regulatory expectation. So there is language in the FSMA law that says this. Under your hazard analysis and risk-based preventative controls, there is a statement that says controls should be minimized to prevent the occurrence of identified hazards. So obviously allergens should be a potential identified hazard when you're doing your risk assessment. And it should include the use of environmental and product testing programs. So again, what are some of the elements then of an effective environmental monitoring program? First and foremost, you need a baseline sanitation program that, number one, identifies allergens, the source of allergens in the facility, and number two, you have a written plan to be able to clean those allergens from those potential harbor sites. The second element is an environmental testing program to confirm the effectiveness of what you've just done, and number one. The third thing is to make sure that you evaluate the results of that testing program and do a root cause analysis when you find positive environmental samples. And then based on that root cause analysis, you're going to develop written corrective actions that are going to be preventative to help you eliminate future occurrences of unwanted allergens in your facility. So within that environmental monitoring program, what should be your goals? Again, finding allergens in the environment before they contaminate product. And so what I like to counsel people when I go into companies and help them build these programs is it's much better to invest your testing dollars up front and do a seek and remove program than it is to do an environmental monitoring on a very easy to clean surface. Because if you're doing that, then you know your test results are always going to come back negative and you really have nothing to build an effective program around. So again, my philosophy is look for areas where you think you have the potential for environmental allergen contamination and then develop a cleaning program to be able to remove those allergens. The second item then is to assess the effectiveness of this new cleaning, sanitation, and your employee hygiene practices to make sure that those behaviors then keep those allergens under control. A question that's often asked is where do you test? And like environmental monitoring for pathogens, the use of a zone approach is an appropriate way to build your program. What you're going to be looking at, obviously your highest risk are going to be direct product contact surfaces because that's where allergens are more easily transmitted into a finished product. You also need to look at non-product contact surfaces, particularly those surfaces that are in very, very close proximity to direct product contact surfaces. So what we're really looking for then is identifying these sampling sites based on risk. So again, direct product contact surfaces are going to be your greatest risk. We advocate using a facility grid. You can do random rotation amongst grids. However, I would argue that if you know you have areas that are more difficult to clean, please include those more frequently as sampling sites. Also, in your written plan, you need to detail the frequency of sampling. In other words, how often are we going to do EMP monitoring for allergenic proteins? Unfortunately, I can't give you a hard recommendation, but I'll kind of show you how you can do that in a little bit. You need to dictate the number of samples you're going to take, how you're going to collect those samples, what test method you're going to deploy for the specific allergens you're looking for. And again, some people just test for protein rather than test for allergenic proteins. So again, this needs to be detailed and rationalized in the EMP plan. And then what corrective actions are you going to use when you have an unacceptable test result? Okay, where are some locations would be good to consider for sampling sites? Well, obviously, if you're a facility and you are manufacturing products where you want to control allergens, meaning that you want to make sure that you are not putting labels on your products that declare every single allergen that could be present in a food, because what you're really doing in that circumstance is you're scaring off consumers. A consumer is not going to believe that you really have control of your manufacturing facility if you have a very simple ingredient list and then you say product manufactured in a facility that might contain, and you list all the potential allergens. That is a really, really poor way to control your allergen risk because it scares off consumers. They're not going to believe you know what you're doing. And it really isn't going to reduce your liability because a lawyer is going to come after you anyway, because what most allergen-sensitive consumers are doing, they're reading the ingredient lists. And if the allergen they're sensitive to is not listed as an ingredient, they're going to eat that product. And they're not going to pay attention to that label because they're trusting that you are keeping those allergens out of those products. So if they get sick or die, they're still going to sue you. You need to also identify areas then that are easily contaminated by employee traffic patterns and behaviors. Consider the use of compressed air and dust movement. This is a fantastic way to do dry cleaning in a facility because it moves debris away from equipment, but it also is fantastic to distribute allergenic proteins all throughout your facility. So like microbiological cleaning and sanitation, the use of compressed air and high-pressure water sprays are usually discouraged because of that potential for aerosolizing these food safety risks all throughout a facility. Obviously, direct product contact surfaces are critical, and areas where the product is exposed to the environment and before package closure also is critical because of that potential for residual dust and debris falling onto the product. So like environmental monitoring, the critical areas are going to be your direct contact surfaces. Your control areas are going to be surfaces that are in immediate proximity to those direct product contact surfaces. Unlike microbiological monitoring, where you might want to go out and look at other areas maybe further removed from these critical zones, we really don't think that those are important areas to be able to do allergen testing, simply because it's more difficult for the allergens to move. They're not multiplying like microorganisms in those locations. So the risk, I think, is much lower in further removed areas. So in this case, we're going to define Zone 1 as that direct food product contact surface. And usually this is any area between when the material is brought into the facility to when that product is in the final package closure stage. These are just a listing of some of the places you can look for allergens. Zone 2 areas are going to be in areas in close proximity to Zone 1, And in this case, what we're really thinking about for sampling sites are going to be areas within enclosed equipment. So in other words, if the allergenic protein is present, it's not going to easily get out of that enclosed equipment area. And so some of the zone 2 areas may be contaminated. You could look at vacuum cleaners as an example. So you could collect the dust that is removed in those vacuum cleaners for the presence of allergens. You could look at brooms as well as other dust collection areas as appropriate sampling sites. You may also want to consider air handling unit filters as a sampling site, and that gives you some feeling for the possible prevalence of allergenic protein in the air column within a facility. So what samples are appropriate for collection and assaying to be able to give you data to answer, do I have an effective program or not? Finished product obviously is the ultimate sample, but you may want to consider where in the production line you collect the finished product. So an appropriate way to consider this would be maybe taking the first run of a non-allergen containing finished product through a recently cleaned and sanitized production equipment, because presumably that first run is going to be picking up more of any residual allergen than perhaps the last run that goes through. So rather than just randomly collect samples from an entire finished lot, you might want to focus your attention on that first run. You could look at product residue that remains in a piece of equipment both before and after cleaning. You could do swabbing in of your non-contact your contact surfaces as well as your non-contact surfaces. Again, if you're have pneumatic conveyor belts in dry processing environments, you could collect samples of that air going through those systems. And then you could take samples, if you're doing CIP, you could take samples of the rinse water after cleaning and test those for the potential of allergenic protein. So some additional questions that we hear frequently is why are you sampling and how will you use the results? Obviously, trending results is very important. So you can do both qualitative testing, in other words, presence or absence of the allergenic protein. You could also potentially do quantitative assays for determining whether or not your cleaning and sanitation program is effective at reducing the levels of allergenic protein. You should establish effective alert and action limits, and from those you should evaluate those trends to make sure that you don't have any unwanted excursions, and then develop corrective actions that can be implemented in response to an unacceptable allergen test result. So in terms of sampling plans, these are some questions that you should be asking is, why are you doing this sampling? What are you going to be testing for? What capabilities of the analytical method, in other words, are there analytical methods that have the sensitivity that you need, and are they effective for analyzing the particular protein in the matrix that you're testing? And then how we use this data. So where do you sample? And then when do you sample? In other words, how often? There are a number of ways you can think about developing a sampling plan. You could do statistical sampling, you could do risk-based, you could do stratified random, and you could do monitoring versus investigating. So I tend to encourage people to think about risk-based, developing risk-based sampling plans that are based on the risk assessment in your facility with your products. I also argue that when you first get started, what you're really doing is you're developing a large test data plan that you're really doing for an investigative purpose. And then based on that data set, then you can devise a routine monitoring plan that is appropriate for your facilities. Some of the things that are going to help you determine how many samples and where to sample are included in this slide. So you need to know the history and trends in the facility, the features of your facility, the types of products and the allergens that you have in your facility, how those allergens and products move throughout your facility, and what are your effective control strategies. So one way that, just to come up with a number that the pharmaceutical industry used to use to qualify a facility for pharmaceutical production is shown in this slide. And so what you're doing is you're just taking your work area, in other words, you take square feet, and convert that to square meters, and then you take the square root of that number, and that gives you a sample volume of 15 in that particular square footage. So is that a defendable number? Maybe. But you really are going to have to come up with a defendable number based on your risk, based on the complexity of your facility, and you're going to need to justify that when an inspector, an auditor, or a customer comes in and asks, how did you come up with that number? So I can't give you the right number because I don't know what it is for your facility. So again, I would argue that when you first get started, sample numerous sites and use large surface areas to be able to assess the degree of contamination and identify potential harborage areas. Once you have that identified and you know that your control programs are working, you can scale back your testing program as appropriate to your situation. I do want to caution you, though, that you need to increase your frequency when any of these situations occur. So if you have ingredient changes, you need to make absolutely sure that you are validating that your supplier has an allergen control program and that you're verifying that those ingredients do not have unintended allergens. Anytime you have construction events that can disrupt potential allergen harborage sites or change how allergens might move into your process, you need to revalidate your allergen management plan. And you need to do that by, again, collecting data that informs your decisions. Anytime you install new equipment, and lastly, anytime you have unwanted allergens that are found in your monitoring plans. And that can include both product testing, ingredient testing, as well as environmental testing plans. So here's a schematic, plant mapping. And again, what you're looking for is both employee movement and equipment movement because they have the potential then to cross-contaminate all kinds of work areas within that processing facility. So I want to give you some examples on places that you can consider for pulling an environmental monitoring sample. So in this case, this could be a bulk storage bin. Could be raw materials, could be finished materials, could be ingredients. And one way you could test the effectiveness of your cleaning and sanitation and just go inside that bin after a cleaning program, collect that environmental swab sample, do the environmental testing, and it could give you a result. Well, the problem with that is that stainless steel surface is probably very easy to clean, very easy to get the allergenic proteins away, and so you're going to be collecting a bunch of data that's going to be non-detect. If you look at areas that are more higher risk in just a very simple piece of equipment like this, you may want to look at that slide valve down at the bottom. And so you could see dust and debris on this slide valve that might be more difficult to clean, but it has the potential to cross-contact every material that's removed from that bulk container. In this case, if you're using mills to grind product, you see all the debris and dust around those mills that aren't well isolated to those mills but have the potential to get all throughout the facility. So you can collect some of that product dust as an environmental sample. Again, you could look at mixer exits as a way to collect samples. You could collect the material that's being collected on your inline magnets, and this is a slide that shows that material, and you could test that material for the presence of allergens. So again, some key issues related to collecting your sample are shown on the slide, and that is make sure you don't cross-contaminate your sample with dirty hands, dirty attire, or dirty sampling collection devices. And again, when you first get started, sample numerous sites and use large surface areas to gauge degree of contamination. Please make an effort to find these hard-to-clean areas, and then use these results to educate employees to better affect their ability to manage their cleaning and product segregation programs. I want to say a few things about the use of swabs and sponges. We want to make sure that you're using collection devices that are recommended by the kit manufacturers. In other words, if you're doing in-house testing or you're using a third-party provider like Eurofins, make sure you're using the appropriate sampling devices. And the reason why I want to make that important to you is if you're using sponges or swabs for microbiology environmental testing, some of the ingredients in those sponges and swab transport media may contain allergenic proteins. So for example, tryptone, peptone, soy, those can contain milk proteins as well as soy proteins, both of which are allergenic proteins. So those would potentially light up your test result and not have anything to do with the prevalence of those proteins on your surfaces. So I want to say a few things about the allergen testing that we do at Eurofins. Our Allergen Center of Excellence is at Eurofins GeneScan in New Orleans. We do lots and lots of allergen testing, both environmental samples as well as finished product samples. And we have broad experience with a wide range of products. And I just want to make sure that you understand that there are many, many kit manufacturers out there producing kits for testing allergenic proteins. It's very important that you validate the effectiveness of those kits for your products and for the proteins that are important. And just to reinforce that, yesterday I learned that one of the major kit manufacturers has a kit that's not able to differentiate soy protein from other legume proteins, peanut protein from other legume proteins when at very, very low population levels. And in this case, it was fenugreek, which is a spice, will light up a peanut protein at very, very low levels in a complex mixture. So that would give you a false positive peanut protein test when fenugreek is used as an ingredient. So that's just a recent example. So make sure that you know that whatever test platforms you're using are actually being done well. So one way you can do that is do your own in-house validation, or you could contract with a laboratory that'll help you do that as well. In terms of method selection, I want to argue don't make it harder than it has to be. Make sure you're sampling for the type of allergens that you're expecting in the room or in the facility. Make sure you're using appropriate sampling collection materials that are accepted by the industry. If you are using ATP kits to monitor cleanliness, be aware that ATP is not a protein. It is an inorganic material that really does not tell you whether there's protein present or not. Many of the ELISA-based methods are specific for the specific allergenic protein. So I want to give you an example here. A kit that's used for milk protein casein will not detect whey protein beta-lactoglobulin. So you need to look at your ingredients to make sure that you are using the appropriate kit for the appropriate allergenic protein. Also, when you're considering method selection, be aware that many of these proteins can be denatured by heat processing or by other food processing methods such as acidification or fermentation. And when you change that primary, secondary, or tertiary structure of those proteins, it may make those proteins less reactive to the ELISA kits, and therefore they may not detect those allergenic proteins. In such circumstances, you may want to consider using DNA-based methods. So in this case, what you're looking for is the nucleic acids that are associated with the original source material of those allergenic proteins. So for example, if you are looking for milk proteins and they are denatured or complex, you can look for bovine DNA, and that could potentially tell you whether or not milk proteins are present. Also, if you have an allergenic protein there where there is not a very effective ELISA method or other kind of kit out there, then PCR may be the only way to be able to answer the question, do I have that allergenic protein present or not? There are some new technologies out there that include LC-MS that could look for simultaneous multi-protein detection, particularly when these proteins are present at very low levels and in complex materials and complex samples. So rather than doing multiple ELISA kits for many different allergenic proteins, you may want to consider what might be a more expensive test, but because you're able to generate multiple data points, it might wind up being cost competitive to do that kind of a screening. So here's an example going back to the recent cumin adulteration thing that I showed you at the very start of the talk. And this is something that Eurofins GeneScan just finished up, looking at the difference between a PCR reaction and an ELISA reaction for peanut allergenic protein. And so when you look down, the sample types on the first column on your left are going to be ground cumin, ground peanut shell, cumin that has 10% ground peanut, cumin with 1%, and cumin with 0.1% ground peanut shell. And if you look at just simply ground cumin, PCR reaction was negative, and the ELISA reaction was less than the limit of quantification, and that is 2.5 ppm. If you look at ground peanut shell, that gives a positive PCR reaction and a positive peanut protein reaction with a concentration of greater than 20 ppm. Cumin that has 10% peanut was positive by both methods. When you reduce that cumin down to 1% peanut, this could be unintentional contamination. Example, the PCR was positive, but the ELISA was less than the limited detection. And then also cumin with 0.1% peanut shell, again, might be an incidental contamination event that also was positive by PCR and negative by ELISA. So you can see that these PCR tests give you a much greater level of sensitivity than an ELISA kit. All right, so let's move on to data interpretation and management. What types of data are you going to be collecting? What do the results mean? You're going to keep records of this testing data. You're going to establish performance targets that you can implement in your facility. Establish baselines for what is acceptable and unacceptable, do trend tracking, establish an action plan, and then form a response team. What are some elements you need in your records? We recommend that you have date and time of sampling, who's collecting those samples, where the samples are being collected, when are they going to be submitted to a laboratory for testing, what the results are, and then a section for corrective actions. Who should you have on your response team? These should include your quality assurance and your QC personnel. They should include the sanitation supervisor and the members of that crew. Should also include individuals from production and their crew. And then make sure you have maintenance and the maintenance crew also involved. All of these individuals are going to be helpful in you managing when you have an out-of-spec situation on those test results. Some elements you should have in your written corrective actions are included on this slide. You need to make sure you limit access to the area. So how are you going to do that? You're going to break down and inspect that equipment to get an understanding for how do we have a positive environmental sample. You're going to thoroughly clean and re-sanitize all that equipment, all those surfaces, and any tools that might have been used in that area. You're going to increase sample frequency to make sure that you've got that area back under control. And one way to consider that is after you've done a corrective action, if you do 3 successive environmental samples, and if those come back negative, then you can go back to your original sample frequency. But you may also want to consider revising your sample location and frequency site plan to include more regular surveying of that area. You also need to ask the question, is my contamination beyond this site that we found that was contaminated? I mean, is it just a localized spot, or do I have a more widespread contamination event? If your pre-op inspection fails, then again, re-clean, re-sanitize, and then resample as needed. And then make sure you don't restart operations until all your tests come back within your acceptable range. So make sure you document your corrective actions. In other words, did we actually do those? And make sure you've got a record of that. Because again, FDA is going to come in and they're going to ask, what was your corrective action and when were your hard clean and sanitation breaks? Because any production that happened on that contaminated surface, FDA is going to consider all of that material to be potentially allergen containing. If you have a recurring problem, you need to ask this question. Do I need to consider removing that piece of equipment and replacing it, redesigning it, or changing my entire production process? Some routine preventative measures are going to include, again, making sure you're not inheriting your supplier problems, looking at the robustness of your testing program, making sure that if you do have some ingress areas, what can you do to prevent those to keep unwanted allergens from getting into your products? Periodic review and monitoring of your good manufacturing programs and your sanitary operating procedures. Doing both in-house and hiring external auditors to come in and specifically asking them to consider your allergen management programs, and then making sure you've got a way to reinforce proper employee hygienic practices. So that concludes the formal presentation. I really do value you investing time with me today, and I hope that if you have any questions after we're completed here, that you can address those by email. I think we're running fairly short on time. So I'm going to turn this back over to John for some concluding remarks. And again, thank you very much. John?
All right. Well, thank you, Dr. Marshall. Appreciate your time in the presentation that you gave. So we are running a little bit short on time, and we did receive a couple of questions, and so we will follow up with you if you did submit a question individually. And for those of you who did not submit a question, here's Dr. Marshall's contact details, so feel free to email him any questions that you have. And at this time, I'd like to remind everyone that the webinar recording will be available for viewing within the next few days. And again, if you have any additional questions, feel free to contact us through this email here on the screen. So that is everything we have for today. Thank you so much for joining us, and have a great day.